This is the last part of the learning unit 3, the gravimetric analysis. Okay, we move to the next part, which is the particulate gravimetry. An analyte is present in a form that can be separated from its solid, liquid or gas matrix. It can be separated by two approaches, which are the filtration and also the extraction method. Okay, the first one, filtration. You have the liquid samples, you can filter the particulate through an appropriate filtering medium. It's either by gravity or suction process. Okay, this is just like the usual way for you to filter out any kind of precipitate. Okay. Choice of filtering medium, it depends on the size of the particulate and the samples metric. There are few choices that can be used. For example, the cellulose fiber filter paper, it have the pore range around 30 micron to 2 to 3 micron, a little bit large in their pore size. And if you choose to use the glass fiber filter, the pore range is around 2.4 micron to 0.3 micron, and the membrane filter is a way smaller than the other types of filter, whereby the pore size range is around 5 to 0.1 micron. Okay, this is for usually for the small size particles. For example, solid aerosol particulates in a gas samples are filtered using either single or multiple stage system. Sometimes you need to use multiple stage system to filter out the particulates because it have different type of particle size. In single stage, gas is passed through a single filter, retaining particles larger than the filter's pore size. Okay, whereas in the multiple stage system, a series of filtering units is used to spread particles by size. Okay, this is what I mentioned earlier. There are few filter size. Then you can collect the particles that pass through the filter according to their respective size of the membrane or the filter. Usually, this type of filtration is commonly used in environmental analysis of water, air, or soil sample. For example, the analysis for suspended solid in water sample. You have the water sample, you need to determine the suspended solid. So you need to filter out the appropriate volume of well-mixed sample of water through a glass fiber filter and dry the filter until all of the water is removed. Okay, at constant weight. To get the constant weight, usually at the temperature of 103 to 105 degree. Okay, this is usually a temperature to remove the water more than 100 degree. Then grain size distribution for sediments and soils are used to determine the amount of sand, silt, and clay present in a sample. Okay, for example, you have the sample of soil. You want to determine the distribution of the sediments and soil. Okay, is whether it have the sample have sand, silt, or clay. So you need to filter out them according to their size. The grain size boundaries for sand silt is around 1/16 millimeter. If it contains silt clay, you need to use 1 to 1 divided by 256 millimeter. So this you can use filter to filter out and get the information of the grain size distribution. Okay, the example of the quantitative calculation. You have 200 ml sample of water filtered through a pre-weighed glass fiber filter. Then, after drying to constant weight at 105 degree, the filter was found to increase in mass by 48.2 milligram. Okay, the sample is 200 ml. You need to determine the total suspended solid for the sample in ppm. So, to determine the total suspended solid in ppm, you need to have the information on the mass of the analyte and also the volume of the solution in milligram and liter respectively. Thus, the total suspended solid for the sample is 48.2 milligram divided by 0.2 liter. Okay, then you have the total suspended solid is 241 part per million. Okay, this is kind of direct question. Next exercise for you to try on, which is to determine the concentration of airborne particulates in an industrial workplace. So you have the air sample for 20 minutes, rates of 75 cubic meter per hour, and the air or the particulate is collected through with a glass fiber filter through a single stage air sampler. Okay, now at the end of the sample period, the glass fiber filter was found to have increased by mass for about 345.2 milligram. Now the question wants you to find the concentration of particulates in the air sample in terms of milligram per liter or also ppm. Okay, these are the important information that you need to focus on. Okay, so to calculate that one, you have 75 meter cube per hour, 20 minutes, so 25. Okay, in 20 minutes, you can collect for about 25. Okay, 7 is times by 20 minutes and can get 25 cubic meter of air, which is equal to 25,000 liter. And the concentration of particulates in the air sample is 345.2 milligram divided by 25,000. You can get 1.38 times 10 to the power of minus 2 milligram per liter. And another way to calculate to collect the particulates is by the extraction method. Okay, it used for analyte of the gas phase, solutes, and polyfilterable solids. Okay, the extraction use of suitable solvent to extract out the solids. For example, if you want to extract the particles from soil, for example, it's not easily to get the ions, so you need to use a suitable solvent to extract all the ions from the soil, for example. And after extraction, solvent can be evaporated to remove out the solvent. So you need to evaporate the solvent, and the mass of the extracted analyte is determined. And analyte can be determined indirectly by measuring the change in the sample mass after extracting the analyte. Okay, that's all for Learning Unit 3. Thank you.